So let's go over some of these, right? Calcium hydroxide. Now, when we're trying to identify what the chemical formula is for a given compound, right, we need to make sure that we can identify the ions. Now, how do I know this is an ionic compound, calcium hydroxide? It contains a metal, which is calcium. So there it is. Calcium is going to be forming an ion, and then the hydroxide is going to be forming an ion. Now, I saw quite a few people write down H for hydroxide. H can form compounds, but that's called hydride. Hydride. Like hydrogen, chlorine. Chlorine goes to chloride. Hydrogen goes to hydride. All right? So that is not what we're after. And, you know, if you can't find it, then usually it's a safe bet to go look on the polyatomic ion chart. And if we look, we see that there's something called hydroxide, and it has a -1 charge. Do I know what kind of a charge calcium will form? I can tell that it will form a +2 charge. Did I hand out a roll yet? I didn't hand out a roll yet. I can tell that it'll form a +2 charge because of its location on the periodic table. Right? So, based on the location on the periodic table, which elements can you predict what kind of ion they'll form? Can you predict the kind of ion for all the elements based on their location? What is the group that we really can predict with, did we say? The representative elements, which includes these first 2 columns for our metals and aluminum also there. Okay? So those are all very easy to predict. So calcium is one of those. And we can tell by the periodic table that it's going to have what kind of a charge? +2. Now, if these 2 ions are going to form an ionic compound, we need to make sure that they're going to neutralize these charges in a way, right? Because when we say that this calcium likes to form a +2 charge, that means it's going to give 2 electrons to these species over here, right? So it looks like I'm going to need a second one, right? Now the +2 will balance off those -2s. So the resulting compound will be that for calcium hydroxide, right? Any questions about that one? All right, why didn't we call it calcium 2 hydroxide? Calcium 2. Why isn't it called calcium 2 hydroxide? Well, let's talk about copper 2 chloride. What does the 2 mean in there for copper 2 chloride? Okay, it's helping me know the charge on that metal. True? All right. So why didn't we need help with calcium knowing the charge on that metal? Why wasn't it called calcium 2 hydroxide? It is ionic. It's not transition. It's not a transition metal, right? It's not a transition metal, and there's no other way that calcium will be found in a compound. It always will be found as a +2. Copper, on the other hand, transition metal, can form multiple types of ions, not just a +2, but a +1, right? And even others if you get weird chemistry going on. Okay? So copper 2 chloride tells us that the copper has what kind of a charge on it in this compound? A +2. That's what that 2 is telling us. Don't get confused into thinking that that 2 is telling us how many anions are associated with this cation or anything else. Okay? Okay. In this case, though, it does turn out, because it's chloride with a -1 charge, that is the ratio we're after. Okay? Who got that one? Raise your hand if you got that one right. All right. Excellent. Good job. And our last one here, ammonium phosphate. This is simply looking at what? Polyatomic ion table, right? And seeing that the ammonium ion looks like that. The phosphate ion looks like that, right? So these need to come together in a ratio that those charges will be neutralized. So we need how many NH4s? 3. Okay, so there's ammonium phosphate. Okay, yeah.
How do you know when to put the parentheses and when to just leave it like that you did with the copper?
Oh, here? So here we don't need parentheses around. Parentheses will only be around clusters of atoms, first of all.
The
Polyatomic. Right. Because if I didn't have this, let's rewrite that there. If I didn't have this parentheses here and I put the 3, it would be confusing as to what that 3 referred to, right?
Oh, whether it was the N or the H.
Yeah, the N or the H or why it's there, right? Like if I had a 2 there, right? So that helps me identify where it is. So in this case here, CaOH2 would be a way of saying calcium, 1 oxygen, and 2 hydrogens. But this is trying to say calcium with 2 of these groups on it. Okay? All right. Very good. So, can you tell me the name of this compound? I think I did this one. Did I do that one last time? Don't look back at your notes. Tell me the name of this compound here. Chromium 2 oxide. Now, why did you think that? We got the chromium part. That's pretty straightforward. Chromium. We got the oxide part. Do we need a number, first of all?
No.
Why not?
Because it's not two gases.
It's not a metal and a non-metal? Or what?
It's not two non-metals.
Okay, so if it's 2 nonmetals, or if it's a combination of nonmetals, we don't use numbers. We use like di, mono-di, tri, those kinds of things. So that's when we would indicate that we don't need a number. So that's not the case. Is there any other reason why we know we don't need a number, or do we need a number for this one, or?
Oh, we would, because it's a transition metal, so you don't know which charge.
That's exactly right. Transition metals and intertransition metals have the ability to form multiple charge states. And this is chromium, right? Chromium has the ability to form lots of different kinds of charge states. So now we need to help somebody know what kind of chromium oxide we're talking about. Remember, if I go to the store and I bought you some chromium oxide, you're going to be wondering, what kind of chromium oxide did that guy buy me, right? So we need to be able to explain to people, all right? So what is that number supposed to be telling us? Does it tell us how many oxygens there are on the chromium? No. It's going to tell us the charge on the chromium. What is the charge on this chromium ion right here? It's a 4. 4 plus 4. So this is called chromium 4 oxide. Okay? Does everybody know how we knew it was a plus 4? No. Okay. So what we have here, that species, apparently they're telling us that 1 chromium gets together with 2 oxygens. Oxygen, we know, has to have a -2 because of its location on the periodic table. It's a representative element. Okay? So then this must be a +4 to balance out those there. Did everybody get a chance to get the roll? If you change your mind, you need it again, it'll be up here for a while. Okay? Excellent. How about this one here? Yes.
If the 2 is in the top right corner instead of the bottom right, it would be different, correct?
If the 2 is in the top right corner. Oh, like CR, like this?
Or is that the same?
I don't know what that is. I'm not sure when you would see that sort of a thing. Have you seen that thing before?
Yeah.
When? When do we see that?
I don't know. I randomly saw you say the T11.
In the what?
T11.
Huh? Oh, maybe it was like this. -2.
Oh, yeah.
Okay. and I think it's actually CR2O4, 2 minus. That is a polyatomic ion, a chromate ion, or a dichromate ion, right? So yeah, when it has a charge up here and multiple atoms here, then it's a polyatomic ion. And you won't find it by itself. Well, yeah, depending on the question, I guess you might find it by itself. All right, so what's the name of this compound here? Phosphorus trioxide. Phosphorus trioxide. All right, anybody want to talk about that one? Is that crazy? Why did we use the tri this time? Because it's not an ionic compound, is that what you said? That's right, it is a molecular compound. It's made of all non-metals. Okay, how about this one here? Sulfur dioxide. Okay, how about this one here? Is that one on your list? What's it called? Sulfite? Sulfite? All right. Okay, so got some charge there, then it's all of a sudden a polyatomic ion. Right? No charge, no polyatomic ion. Let's see if there's any others that we could use. Oh, here's some good ones. How do you name something like this? Do you remember this business? What do you think? What is it? Yeah. Okay. So, what kind of a chemical is this? A hydrate. Very good, a hydrate. So we say the name of the chemical up front, and then we add on, like in this case, dihydrate. So what is this? Calcium sulfate dihydrate. Very good. How about this one?
Oh, it had the transition.
It's a transition metal. So what does that mean we have to do? Got to throw in a number there to help people know what? What does that number help people know? The charge on the metal. So we're looking at cobalt 2 chloride hexahydrate. Very good. Iron 3. Iron 3, you got to finish up the rest of that though, right? Iron 3 iodide, sorry, that's right, iodide. Trihydrate. Iodate is actually a polyatomic ion that's not on your thing. One more here. Did you not get that one yet? Iron 3 iodide. Iron 3 iodide. Trihydrate. Okay, next one here. What's the correct name for Cu2S? What is that? C, B, or A? Or D? A? It'd be C, B. How about you talk to your neighbor and convince them? The right answer will be the right answer democratically today. It will not be the right answer outside this room. The right answer is what you guys decided is. All right? So, you must convince your neighbor of your answer. We have to be unanimous though on our decision. So, did you get it? All right. You don't put the one in parentheses in between? No, you need to tell people, because if I told you I bought some copper sulfide, you don't know if it's which one, right? I don't know. We're going to decide. What did you guys decide? C? Are you guys in agreement? Anybody need convincing? What do you guys decide? B?
Yeah.
Yeah? Okay. You guys got to talk with these people then, because there's some disagreement. Huh? C? You got to talk with these people then. What do you think? C? Did you guys think it was... You're going with C? You guys aren't convinced yet? Well, it shouldn't be a matter of makes sense. There should be like a absolute. We know or we don't know, right? So, when they say C2S, right? And this is what you should do maybe. Maybe this is what you should do when you get to a scenario where you don't know. They're saying how many coppers? Well, Cu2, right? There's 2 coppers. And then there's how many sulfides? 1. So, the charge on this side has to equal the charge on that side, right? What do we know about the charge on either of these sides? Sulfur is a -2. Okay? Copper must be a +1 here on both of these. Is that true? Okay, so what does that mean the number in the middle should be? That number in the middle, does that tell us how many coppers there are? Does it tell us how many sulfurs there are? It tells us the charge, not the collective charge, but the charge on every individual metal that's there. True? Right? So it's copper 1 because that's a +1 on each of these coppers. Okay, good. Anybody else want to talk about that one, any? Okay, well, you know, we've kind of come to an end here. I have the test here. We could go over some problems that might be on the test. Okay. Let's go way back really quickly to make sure we don't forget this. One time we talked about, and there haven't been a whole lot of questions like this. All right, if I'm looking at this burette right here, or this measuring device. Okay? Can you tell me an appropriate number that I can write down? So essentially, this is my... Huh? What's that? Meniscus. Yeah, that thing it's called the meniscus, and we measure it from the bottom, right? I mean, I think we never talked about that in this class, but that's something you guys might have absorbed. I don't know, but now you know. We measure from the bottom. So, can you talk to your neighbor and see what kind of a number will be a legitimate number to get out of this thing? Okay? Remember, this is about significant digits, right? Significant digits. What kind of a number should we be able to get out? Okay, did you guys figure this out? What's a reasonable value here? 1.6. One vote for 1.6. Anybody else have a vote out there?
We said
1.57. Any other votes? 1.55. 1.56. It's closest without going over, remember, so. 2. Okay, so which one of these would be legitimate numbers based on the information given? Well, the thing that we're trying to recognize is that, yeah, this is somewhere like 1.5, 1.6, or whatever. Well, what's wrong with this value? Not enough sig figs. Because we're supposed to take one estimate. And so, if I know it's at the 6, I mean, if that's what my estimate is, then I'm saying 6, 0. Because I can see that this is 5 and this is 6, right? So, without that, these are the only 3 that are feasible values. This would be feasible also as long as it had, you know, I mean, somebody could say, yeah, it looks like 1.60 to me. Okay? This value here, 1.560, or 1.590 maybe, that's not feasible value, right? Why not? Too many sig figs, right? You only get to carry one estimate, right? Okay. Looking at some boxes over here. Atom A is represented like this. Atom B is represented like that. When we had our discussions about the different types of matter, can you try to classify these? Classify these as different types of matter. Maybe I ask you first, which one of these are pure substances? Which one of these are pure substances? Talk to your neighbor, and you know, that's not the only thing you can talk about. You can say, that one's not a pure substance, it's a blank. Or that one is not only a pure substance, but it's also a blank, right? So have conversations about what these different boxes represent in terms of the different classes of matter we had. Okay. Any thoughts? Still talking? Let's give you a few more seconds? All right. 20 more seconds. Okay. What do you think? Which ones up here are pure substances? Pure, well, yeah, that's not a differentiation, right? We said pure substances can be broken down into what? Compounds or elements, right? So if you want to say pure substances are compounds or elements, then we could say which ones are compounds or elements. Let's just back up and say what ones are pure substances. Okay, so A, B, C, D. B, is this a pure substance? Yeah, in fact, this is elemental, right? All the elements there are the same. How about C? Is that a pure substance? Yeah, it is. All of these compounds are exactly the same. So that's a pure substance can either be an elemental or a compound. D? All right, so this is a pure substance. Is this elemental? It is. It can be elemental, right? We have said that some elements are diatomic. They go around in pairs, right? So what does A here look like? A mixture. Mixture. Good.
Well, we have to specify between the homogeneous and the heterogeneous mixture.
I don't know. If I wanted to draw a homogeneous mixture, the only thing with that is, if you're talking about homogeneity, you kind of need a little bit of a perspective, right? Because if I draw this, is that homogeneous or heterogeneous? Depends on where you look at, right? But something like this, which one of those is more homogeneous, A or B? Homo means same, and what's the same about a homogeneous mixture? Same amount of the different components in given locations, right? So if I wanted to say, here's a location, do I have the same number of stuff? Yeah. Here's the location, do I have the same number of stuff? Yeah. Here's another location, do I have the same number of stuff? Yeah. So this location, not the same number of things. This location, not the same number of things. This location, right? So this one would make a little bit of is less homogeneous, more heterogeneous, right? All of one is down here and the other's up there. This one's a little more dispersed. But yeah, I don't know if we'll get that sort of a question, but it is important. I don't know what kinds of questions. There might be some questions about homogeneous and heterogeneous. Okay, good. We got some answers there for substances or mixtures, pure substances, compounds. Okay, how about this one? Do you know how to identify how many sig figs are in this compound? Do you want to do that math and see if we can get the right answer? Or maybe you already did it. Okay, did we get an answer here? Order of operations, we need to do this top part first, right? And when you do addition and subtraction, you got to line them up like this. 2.111 minus 0.0311. Somebody put that in their calculator? What do you get? 2.0799. Is that right? Okay. Now, where do we cut it off at? Where do our significant digits cut off at? Right here. True? So, this has to round up to 2.080. And then we take 2.080 and we divide it by 0.97183. The answer here doesn't really matter, does it? How many significant figures are we going to have? Our answer? How many significant figures here do we have? That's 1, 2, 3, 4. Here, 1, 2, 3, 4, 5. So our answer is going to be how many significant figures? 4. 4 significant figures. All right, the things to remember with this problem is make sure you line up your addition and subtraction. Even if it's really obvious what's going on, make sure you line that up. Okay? All right, so then where are we here? Oh, over here. What cation has a +2 charge and 8 electrons? What cation has a +2 charge and 8 electrons? Got it? What is it? What is this cation? Neon? So we have neon with what? +2 charge, is that right? So if it had a +2 charge and 8 electrons, what does that tell us about how many protons it has? It has to have 10 protons, right? Because that +2 charge is an indication of the difference in the number of electrons and protons. Okay, very good. How about this one down here? Metal X has the same mass as metal Y, but metal X takes up less volume. Which is more dense? Metal X or metal Y? Is this one easy? What is density? What is density? Density is, what are our units for density? We had a handful of problems early on, right? Mass over volume. I think you should talk to your neighbor, see if they know. They might have an idea for this one. Don't want to talk to your neighbor? If you're afraid of your neighbor, you can come to me and we'll get you a different neighbor. Maybe it would help to give numbers to our masses and volumes for X and Y. Do we got it? Is it easy now? Okay, which one is it? Which one's more dense? Are we confident? Should we put some numbers up here? Metal X has the same mass as metal Y. I'm going to draw a picture. Okay? Here's a pile of metal X, and here's a pile of metal Y. Metal X has the same mass, so I'm going to say 10 grams. 10 grams. All right? Metal X takes up less volume. So what does that mean? I have to make this pile a little bit smaller. Right? Maybe I'll make this one a little bit bigger to... Okay, they're both 10 grams. Let's give this a volume. Somebody tell me a number. 3 milliliters is a unit of volume. What about this one? 7 milliliters. Okay, so which one what's the density of this one? Grams divided by, or mass divided by volume, so 10 over 3. So what is that? About 3.3 grams per milliliter. This one here? 1.42 grams per milliliter. So it looks like X is going to be more dense. Okay, see how that works? Excellent. We have time for one more. Okay, this is species right here. Can you tell me how many protons, electrons, and neutrons? This is always a fun game. How many protons, electrons, and neutrons in this species right here? Protons, electrons, and neutrons. Which one's the easiest? Protons, right? Because you just look on the periodic table and the number tells you. So, how many? 3. 3 protons. What's the next easiest? Neutrons? How do we find the number of neutrons? Yeah, because this is the mass. If 3 of those are protons, the other 4 must be what? Neutrons. Very good. How do we find electrons? What's the answer? I don't know the answer yet. If it was no charge, if there was no charge, then it would be the same as the protons, right? So if there's a -3 charge, it's 3 more than the protons, right? So 6 electrons. Should we do that one again? All right, I'll erase it. Do it again. No, just kidding. Okay, here's another one. All right. There we go. Protons, neutrons, electrons. Protons is the easiest, we said. How many protons? 10. Neutrons? 8. Electrons? 3. I changed it to a +7 right at the end. I don't know if you guys saw that, but. So what does that mean? More electrons or more protons? More protons. So how many electrons? 3. Okay, good. Looks like you got that one all right. Okay, here's one really quick. X23 and X24, and it's 62% this and 48% this. Wait, 38%. 38% that. 2 isotopes. What is the average mass of X?